Welcome to Tech and Trek, exploring the past, powered by the future. Am I the only one that didn't know the ocean covers more than 70% of our planet's surface? Yet it remains one of the most mysterious and unexplored frontiers on Earth. Its vastness is both awe-inspiring and intimidating, a true testament to nature's grandeur. As you stand on the shore looking out at the endless horizon, it is easy to forget the depths that lie beneath, concealed from our sight and understanding. The ocean is not just a habitat for marine life, but a world shrouded in secrets, waiting to be unveiled. Beneath the waves, a shadowy realm exists, teeming with life forms adapted to survive in extreme conditions. These creatures and their habitats are largely unknown to us, hidden in the abyssal plains and dark trenches. The deeper you dive, the more remote and inaccessible it becomes, with pressures so intense that they can crush unprotected human bodies. Yet this dark and silent world is crucial to the health of our planet, influencing global climate, weather patterns, and even the air we breathe. As we delve deeper into the marine kingdom, we enter a world that is both fascinating and foreboding. These secrets reveal dark truths about human impact on fragile ecosystems. Deep-sea mining poses significant risks, causing irreversible damage to habitats. Pollution presents a grim picture, with plastic waste and toxic chemicals endangering marine life. Unexplained underwater noises hint at unknown creatures or geological activities. It is a reminder of our responsibility to protect and preserve this vital part of our planet. Deep-sea mining is a significant threat to marine ecosystems. It involves extracting valuable minerals like manganese nodules and cobalt-rich crusts. The environmental costs are substantial and often overlooked. Mining disturbs the seafloor, damaging habitats evolved over millions of years. Sediment plumes smother marine life and degrade water quality. The long-term ecological impacts are still largely unknown. Loss of endemic species could lead to irreversible damage. We need cautious and well-regulated approaches to preserve these habitats. The seafloor is a mosaic of diverse habitats, each hosting unique communities of life. From hydrothermal vents to cold seeps, these environments are characterized by extreme conditions, such as high pressure, low temperatures, and complete darkness. Despite these challenges, a myriad of organisms thrive here, many of which are specially adapted to their niche habitats. However, the fragility of these ecosystems means they are particularly vulnerable to disturbances. Hydrothermal vents, for example, are hotspots of biodiversity, with communities that rely on chemosynthetic bacteria for energy. These vents provide a rare window into life's adaptability, supporting species that are found nowhere else on Earth. Deep-sea mining poses a direct threat to these delicate ecosystems. The removal of vent structures and the associated disturbance can obliterate entire communities, disrupting the intricate balance that sustains them. Cold seeps are another critical habitat, where methane and other hydrocarbons seep from the seafloor, supporting specialized microbes and higher organisms. These seeps play a significant role in regulating methane emissions, a potent greenhouse gas. Disruption from mining activities could release large amounts of methane, exacerbating climate change. The loss of these habitats also means the loss of ecosystem services that they provide, which are often not fully appreciated until they are gone. The slow growth rates and long lifespans of many deep-sea species further compound their vulnerability. Unlike shallow water ecosystems, where recovery can be relatively quick, deep-sea habitats take centuries, if not millennia, to recover from disturbances. This makes the impacts of deep-sea mining not just immediate but long-lasting, with potential consequences that could span generations. The pristine nature of these environments underscores the importance of protecting them from irreversible harm. Section 3. Long-term consequences and unknowns. The long-term consequences of deep-sea mining are still largely speculative. However, the potential for widespread ecological damage cannot be ignored. Even with the best mitigation strategies, the deep sea's unique characteristics make it difficult to minimize impacts. The slow pace of life and the complex interplay of species mean that any disruption could have profound and lasting effects. One of the major concerns is the potential for genetic loss. Many deep-sea organisms have unique genetic adaptations that could hold the key to new medical and technological advancements. By destroying their habitats, we risk losing these valuable genetic resources before we even understand their potential. This loss of biodiversity is not just an environmental issue, but a loss for humanity as a whole. There is also the issue of cumulative impacts. Deep-sea mining is not happening in isolation, but alongside other human activities like commercial fishing, pollution, and climate change. The combined effects of these stressors can lead to unforeseen consequences. This interconnectedness highlights the need for comprehensive environmental assessments and regulations. Finally, the ethical implications of exploiting the deep sea cannot be overlooked. The deep ocean is one of the last frontiers on Earth, a place of mystery and wonder. The question of whether we have the right to exploit these environments for short-term gains is a philosophical one. As we weigh the benefits and risks of deep-sea mining, we must consider the legacy we leave for future generations. In conclusion, deep-sea mining represents a significant threat to the marine kingdom. The fragility of seafloor ecosystems, coupled with the unknowns of long-term impacts, calls for a cautious and responsible approach. Protecting these hidden realms is not just about preserving biodiversity, but about safeguarding the future of our planet. Enigmatic creatures of the deep. The deep sea is home to some of the most enigmatic and bizarre creatures on the planet. Among these are the anglerfish with its bioluminescent lure, and the gulper eel, which can unhinge its jaw to swallow prey. The vampire squid with its cloak-like webbing seems like something out of a nightmare. The deep sea harbors countless species yet to be discovered. However, human activities like mining and pollution threaten their habitats. Protecting these creatures is essential for preserving the deep sea ecosystem. Unusual adaptations for survival. Survival in the deep sea requires remarkable adaptations. Bioluminescence is a striking adaptation found in many deep sea species. It is used for attracting mates, luring prey, and deterring predators. The anglerfish's glowing lure mimics small prey to attract larger fish. Another adaptation is the capacity to withstand extreme pressures. Flexible, gelatinous bodies help deep-sea creatures endure crushing forces. The abyssal grenadier lives at depths with immense pressure. These adaptations offer insights for human technology and medicine. Chemosynthesis is another adaptation seen around hydrothermal vents. It utilizes chemicals like hydrogen sulfide to produce energy. This process supports ecosystems in toxic environments. Studying these organisms expands our understanding of life's potential. Deep-sea gigantism is observed in some species. The giant isopod can grow up to half a meter in length. This adaptation is due to cold temperatures and high pressures. These adaptations illustrate the incredible diversity of deep ocean life. Section 3. The threats to deep-sea biodiversity. The deep sea, despite its remote location, is not immune to human-induced threats. Deep-sea trawling destroys habitats and captures marine life indiscriminately. This practice impacts slow-growing species and delicate ecosystems like coral gardens. The damage is often irreversible, leading to permanent biodiversity loss. Pollution also poses a grave threat to deep-sea environments. Plastics and debris accumulate in the depths, creating hazards for marine life. Microplastics have been found in deep-sea organisms, indicating widespread pollution. Climate change exacerbates these threats. Rising temperatures and shifting currents alter food webs and ecosystem dynamics. Ocean acidification affects organisms with calcium carbonate shells, like deep-sea corals. Marine noise pollution disrupts deep-sea life. Noise from industrial activities interferes with marine animal behaviors. The deep sea is a reservoir of unique biodiversity. However, it is under severe threat from human activities. Protecting the deep sea is imperative for preserving its hidden treasures. Section 1. The perils of plastic pollution. Plastic pollution is one of the most pervasive threats to ocean health. Millions of tons of plastic waste enter the oceans annually, breaking down into microplastics. These particles are now ubiquitous in marine environments. Marine animals often mistake plastic debris for food. Sea turtles consume plastic bags, mistaking them for jellyfish. This ingestion can lead to intestinal blockages and death. Birds, fish, and marine mammals are similarly affected. Microplastics add another layer of complexity. These fragments are ingested by a wide range of marine organisms. Once ingested, microplastics can transfer toxic chemicals. These chemicals can cause health issues, including reproductive problems. As microplastics move up the food chain, they reach human consumers. Floating plastic debris can create large patches, disrupting habitats. On the seafloor, plastic waste can smother benthic habitats. The visual blight of plastic pollution is a constant reminder of environmental degradation. Reducing plastic production and promoting sustainable alternatives are essential steps. Improving waste management is crucial in mitigating the damage. Protecting marine ecosystems requires urgent action. The pervasive nature of plastic pollution underscores the need for global cooperation. Addressing this crisis is vital for the health of our oceans. Section 2. Chemical dumping and its hidden dangers. Chemical dumping is a dark threat to marine ecosystems. Industrial activities release toxic substances into the oceans. These pollutants can originate from direct discharge or runoff. Once in the marine environment, these chemicals have devastating effects. Mercury dumping is a notorious example. Mercury accumulates in marine organisms through biomagnification. Its concentration increases up the food chain, posing health risks. Mercury poisoning can cause neurological disorders. Pesticides also find their way into the oceans. Chemicals like DDT can remain in the environment for decades. These substances disrupt endocrine systems, leading to reproductive failures. Industrial and pharmaceutical waste introduces other toxic substances. Pharmaceuticals can promote antibiotic-resistant bacteria. The presence of these contaminants highlights the need for stricter regulations. Better waste management practices are crucial. The hidden dangers of chemical dumping demand greater attention. Monitoring and regulating hazardous substances are essential steps. Cleaner industrial practices are necessary to protect marine life. Section 3. Far-reaching effects on marine and human life. Marine pollution has far-reaching consequences for both marine and human life. The interconnectedness of ocean ecosystems means pollution impacts ripple through the entire environment. These effects disrupt food webs and degrade ecosystem services. Marine pollution affects the survival of many species. Coral reefs are particularly vulnerable. Chemicals and sediments can smother corals and lead to coral bleaching. The loss of coral reefs has cascading effects on biodiversity. Marine pollution impacts human communities relying on the ocean. Contaminated seafood poses significant health risks. Pollutants can accumulate in marine organisms consumed by humans. This can lead to health issues, including neurological disorders. The economic costs of pollution affect fisheries and tourism. Efforts to mitigate marine pollution require global cooperation. Reducing plastic use and improving waste management are essential. Raising public awareness about pollution impacts is crucial. Protecting marine environments is about safeguarding our future. The oceans provide critical ecosystem services. Addressing pollution ensures the resilience of our oceans. Section 1. Mysterious underwater noises. The ocean is a realm that continues to intrigue scientists. Among the most perplexing phenomena are mysterious underwater noises. These sounds range from eerie to forceful, defying explanation. One famous sound is the bloop, detected by NOAA in 1997. Its origin remains unknown, with theories ranging from ice quakes to marine creatures. Another enigmatic sound is the upsweep, recorded seasonally since the 1990s. Its source has yet to be pinpointed. The whistle and train sounds add to the collection of curious noises. These sounds occur intermittently, making them difficult to study. Theories range from natural phenomena to unknown marine life. The ocean's acoustics are complex, and these sounds remain mysterious. Studying these noises has practical implications. Understanding their sources can help monitor seismic activity. It can also enhance knowledge of marine life behaviors. Advances in technology bring us closer to decoding these sounds. The ocean's mysteries continue to captivate and challenge us. Section 2. Uncharted deep sea anomalies. The deep sea is rife with anomalies that challenge our understanding. One intriguing discovery is the existence of brine pools. These hypersaline bodies create underwater lakes with distinct boundaries. Specialized organisms thrive in these extreme conditions. Methane seeps release gas from the ocean floor, supporting unique ecosystems. These seeps play a crucial role in regulating greenhouse gases. Hydrothermal vents spew superheated, mineral-rich water. These vents create thriving ecosystems in lifeless areas. Species around vents rely on chemosynthetic bacteria. The extreme conditions challenge our understanding of life's adaptability. Geological formations like the Lost City hydrothermal field intrigue scientists. These formations hold clues to Earth's geological history. The more we explore, the more we realize how little we know. Continued exploration and study are essential. The deep sea's anomalies underscore the importance of research. Understanding these anomalies can reveal new insights. The deep sea remains a frontier of scientific discovery. Section 3. The Quest for Understanding. The deep sea remains a final frontier of exploration. Advances in technology have expanded our ability to explore. ROVs and AUVs allow scientists to observe previously inaccessible areas. The challenge of deep-sea exploration is technical, logistical, and financial. International collaboration and funding are crucial. Initiatives like the Deep Ocean Stewardship Initiative promote research. Public awareness and interest in deep-sea exploration have grown. This visibility helps garner support for conservation efforts. The deep sea is a vital component of our planet's health. Understanding it equips us to address broader environmental challenges. The quest for understanding is also a quest for sustainability. Responsible stewardship is critical as human activities encroach further. Sustainable practices are essential for balancing resource extraction with conservation. The International Seabed Authority works to establish regulations for deep-sea mining. The deep sea holds many secrets, from mysterious noises to unique ecosystems. The quest to unveil these secrets is driven by curiosity and discovery. Protecting and preserving the deep sea is vital. The deep sea's mysteries are crucial elements of Earth's systems. Continued exploration and study are necessary. The deep sea deserves our utmost respect and care. Section 1. The Unseen Depths. The ocean is a majestic, enigmatic realm. Beneath its surface lies a world of mystery and darkness. Our journey through the deep has revealed a tapestry of secrets. Each discovery sheds light on the balance that sustains these ecosystems. The deep sea's allure lies in its beauty and biodiversity. It influences global climate patterns and weather systems. The myriad of life forms showcases nature's resilience. This hidden world is a testament to the delicate equilibrium. Advances in technology allow us to glimpse underwater wonders. Much of the ocean remains unexplored. The mysteries of the deep sea remind us of our limited knowledge. We must explore with humility and respect. The health of marine ecosystems is linked to our survival. Uncovering the deep sea's secrets reveals the fragile threads that bind us to it. Section 2. Human Responsibility and Impact. Human activities significantly impact fragile marine ecosystems. Deep-sea mining, pollution, and climate change are major threats. These disrupt habitats, threaten biodiversity, and degrade environments. Consequences affect marine life and human communities relying on the ocean. Deep-sea mining risks unknown seafloor ecosystems. Mining causes irreversible damage with long-term consequences. Pollution infiltrates remote oceans, impacting marine life and human health. Urgent need for waste management strategies. Climate change alters temperatures, acidifies waters, and shifts currents. These changes disrupt marine ecosystem balance. Combined stressors threaten ocean resilience. The deep sea is critical for global environmental health. We must protect and preserve the marine environment, foster understanding and appreciation of the ocean's value. Sustainable practices are essential for marine health. Today's choices determine future marine health. A call to action. The marine kingdom's dark secrets compel us to protect and preserve the ocean. The time to act is now, as threats to marine environments escalate. Global cooperation and innovative solutions are crucial. This call to action is for everyone who values our planet's future. Public awareness and education drive change. Understanding ocean threats helps us make informed decisions. Simple actions like reducing plastic use can have a significant impact. Ocean health and human well-being are interconnected. International collaboration addresses global marine threats. Initiatives like the UN Decade of Ocean Science promote sustainable management. Governments, organizations, and individuals must work together. The quest to unveil marine secrets is a journey of discovery and responsibility. We must commit to preserving the ocean's wonders. The deep sea's mysteries deserve our care and respect. Embracing sustainable practices ensures the ocean's treasures inspire future generations. The marine kingdom holds secrets vital to our planet's health. Human impact on fragile ecosystems calls for urgent action. Together, we can protect the ocean and safeguard its future. Thank you for watching Tech and Trek, exploring the past, powered by the future. Don't forget to like, share, and subscribe.